Morning students, previous class we were solving some problems how to derive the relationship between given any physical units. We'll continue with those problems. Let's solve three problems. We'll continue. Fourth one, the velocity v of water waves may depend on their wavelength lambda, the density of water rho, and acceleration due to gravity g. Find relationship between these quantities. The velocity of water waves may depend on their wavelength, the density of water, the acceleration due to gravity. Find relationship between them. Now, sometimes no, in a college, they might not give you that relation. How I was giving no for you in the previous problems, they're directly proportional to something. Suppose if it is not given, only this word problem is like this given, still you can write it. So I'll explain to you how it's to be done. So they will always start with one physical quantity. On the left hand side, there will be only one. So what they are saying is the velocity v. So v will come this side. Depends on or proportional to. Suppose if the word is saying proportional to n, it means the same. So depends on means you have to put a proportional sign. So velocity depends on something else this side. So whatever they have given, you have to just write it in terms of multiplications. So based on the wavelength. So the symbol is already given to you, lambda. What else it is depending on? Density of water. So the other one will be rho. And the third one what is been given is g. So velocity is dependent on all these three things. If another fourth thing was given to you, one more would come up here. If only two things were given, just two. Now every this you just give your random power. So this first one you keep it as A, the second one you put it as B, and the third one you put it as C. So even if they don't give you the relation, you can always write. Now we have to start solving. I told you always put a equal to sign. Just put a K here. Now while substituting, this K is to be ignored. To put the what they are saying V is for velocity. So put the dimensions of velocity. That will be 0. Of wavelength. Wavelength means length. Length means L will be 1 raised to the power A. Density already given to you. What is density? This M1 raised to B. And the third one, acceleration due to gravity. M0 L1 T minus 2 raised to C. Now multiply all the powers inside and then add the powers. 0 into A will give me 0. 1 into A will give me A. Again 0. Students, some of them who have sent me those previous and all problems, they are doing simple mistakes by multiplying the powers and all. Please try to practice as much as possible. The same problems also without looking, always try to solve. You are struggling with the basics, not you all know this formula is substituted this. Then after that, what to be done? You all are getting stuck with that. 0 into C, 0 minus 2. Always multiply the powers inside. No power should be left out. And now you add every corresponding power. M power. You can avoid this step and directly write an answer also, no problem.
Miss, in the middle L, no?
Yeah. So this will be 1. So this will be B. M raised to B. This is L. And this is T. Now you equate the powers. So if you equate, your B will be straight away 0. M power to M power. This is a simple one. A and then minus 2C is equal to minus 1. This is a 1, 2 and 3. From here what you'll get, C is minus 1. So C will be 1 by 2. Now you know the value of B, you know the value of C. Take equation 2 again, put the values here. Put the value of B here, put the value of C here and calculate your value of A. Write the equation 2 again. A you keep like that only. 3 times 0. So 3 into 0 anyways will be 0. And half if you take on the other side, you'll get it as minus half. So you got all the values. B is 0, C is 1 by 2, A is when are simply copying from the board, there's no point. Please try to solve. Because some silly mistakes and all, if you do, you can always check. Sometimes here also can correct. Just don't blindly copy anything.
Teacher, 1 minus half is half, no?
That side is 1 there. Okay, wait 1 second. Sorry, I thought it was 0. So this will be 1. So this would be half. And now we substitute. Row. This order will not matter, okay? G you can always write first, row you can always write on the other side. So this will be half. This you got as 0. This you got as half. Now anything raised to 0 is 1. So that value will go. This whole thing will go. So what remains is this. Now v root of lambda root of g. And both roots you can just put them together. This will be our answer. Once you have finished, you can start trying this. I'll give you only the theory part. Try to obtain the relation. Derive an expression for time period t of simple pendulum, assuming that it may depend upon, sometimes they give you like this, a mass of the bob, length of pendulum, acceleration due to gravity, and d hmm, angular amplitude. Here, this is a constant. Okay, so whenever like this constant is there, like theta, okay, that you can just ignore it along with the k. The theta value will be known. Amplitude means always some number will be. So t is depending on all these things. So this will be m, l, g and theta. But this is a constant, so you can ignore this and just put a, b and c for these three only. A, B, C are to be put for the actual dimensions. So this will be a pure number. Whenever you are writing, you can write k theta together, and you can ignore it. So while substituting, substitute for mass, length, and acceleration. That will be for time. Mass will be, length will be, that is 0, 1, minus 2. By now everyone will be knowing this gravitational constant. Acceleration due to gravity is 0, 1 and minus 2. Now take all the powers inside. M 0, which will be A, B plus C minus 2. And then you equate the powers. M to M, A is 0, B plus C is 0, minus 2C is minus 1. 1 upon minus 2, which will be same as minus 1 by 2. A already got. So write the equation 2, put C here, B will be 1 by 2. B plus C is 0. Okay. Take it on the other side, it will be. Now you substitute your power. Anything raised to 0, I told you, the term will go. So mass will go. So while writing, you can avoid a constant and you can directly write this. C value is minus half. I told you any power negative is there, you can take it down. This will go, m raised to 0 will be 1. Which is nothing but root. If your teachers are using their side theta, you can use, no problem. Just see. Then it will make a common root sign for both of them. So this will be your answer. Next one. With the help of dimensions, obtain a correct relationship between the centripetal force F. They will give you the letters, okay, on a body of mass m moving with velocity v in a circular orbit of radius r. Here the m is there. Now the first one will always be on the left hand side. Centripetal force, correct relationship between the force and the other, whichever terms are there, will be on the right hand side. So now F will be on the left hand side, then mass, velocity and radius will be on the right hand side. So I will write it as F will be this side, mass, if they use small letter, you can use small, if they use capital, you can use capital. V, so this will be A, B, and now start substituting F, force, mass, velocity and radius. Radius will be length. Radius will be length. Force would be M1 L1 C minus 2 mass will be 1, V 0, 1 minus 1, R is length, and now you solve. Anyone, if you have got the answer, you can tell. Anyone having difficulties in adding the powers or still having some doubts how it is to be done, you can please ask. Now we quit. As for that, you'll get A as 1, B plus C as 1,
Is it M1 V2 R minus
and M you did not get?
M1.
M1?
Yes. But minus what I told you to do, take it to the denominator. So A1, so this is anyways B equals to 2. Minus minus will cancel. A we got, B we got. So just write B plus C again, put the value of B here. So C will be minus 1. While substituting, please put it in the correct order. Huh? You put A for A only, B for B, otherwise everything will go wrong. See, be careful here. Don't simply exchange them. Everything will go wrong. So if A check again once. M1, B means 2, and C, this will go down and become plus 1. So the formula will be F is directly proportional to mv square upon R. I should feel like you're some scientist, you are deriving some formula on your own. Next formula I'll derive. Assuming that mass m, sometimes they might not put it in the brackets, they might just give it like this also. Largest stone, you have to read at least 2 times properly, just see if you don't miss out any physical quantity, and can be flowing the river, depends upon v the velocity, rho the density acceleration due to gravity so that m varies with the sixth power of the power of the velocity. I wanted I could have just given all the questions one at a in this just to copy and keep, but then the problem becomes question equivalent and then solution at one place, and then you're all lost. So that's why I'm just spending some extra time. Doesn't matter, but good thing is that one you have the question and below that solution. Otherwise, all the first the questions if I send and keep and then I ask her to do solutions, then you have to keep turning pages. Hope you all are writing, huh? Everyone. Just one key for this stream, like why to make things simple is always keep your notebook complete. Even if you miss something due to network or some class you don't attend, make sure whether you have understood, not understood at that point of time, at least write in your notebook and keep. Because later again somewhere at some point when revising or something, you can always ask your doubt. But if your notebook itself is incomplete, then no point. Then you'll be running around. Until then already you'll be drowning under the tsunami. You won't know which chapter, what is missing, where it is. Okay. The best thing is always keep your notebook complete. And randomly, sometimes I can ask also to send some photos of certain chapter. If that is missing, then I will be in trouble. Now assuming that. So this is rho. So can anyone tell me the relation? What will be on one side? This, those who don't know, it's called as rho. So what will be on the left hand side? Yes, mass. So that will be m. Which all letters will be on the side?
V, rho, and gravity.
Yes, v, rho, and g. A, B, C. Now start solving. Now don't worry about this. Huh? Show that that we'll see what happens at the end. You start solving. Don't think of this line. Normal how you are solving, just derive the relation. M will be first just write that. Yeah. velocity will be then substitute your density and then acceleration due to gravity. L raised to this t raised to 0. Start solving, and then if you find, tell me the value of A, B, and C. What all are getting?
Teacher, A is 6,
Hmm.
B is 1, C is -3.
Okay. Okay, and then equate the powers. And write the relationship, and you will see that V has a power 6. That is what they were asking for. You'll get B as 1. Then the next equation will be now over here. This is 1, 2, 3. Put the value of B as 1. So you'll get two equations. So you'll get it as A plus C equals to 3. Okay. And minus A minus 2C is equals to 0. So see, both of them are in terms of A and C. So what we'll do is, now there are two unknowns we directly cannot solve. So what we'll do is, we'll solve it by elimination method. Or we can express A is equals to 2C and put here. This way also you can. To take the equation 3, put it this side, minus A equals to 2C. So A is how much? Minus 2. Put it in this equation. So C will get as -3. And now take any equation, put the value of C as -3. A will be 3 plus 3, which is, and now you write back. So the relation was V, rho and G. So this was A, this was 1, and this is minus. So directly proportional to, and what has been asked? Sixth power of velocity, which has been proved. So this is like a hint. If you are getting this power, anything other than 6 means something you have done wrong. If you are getting this as 6, it's correct. So only this much only it means. Nothing extra to be done. Any doubts you can ask. Next one. The velocity of sound wave through a medium. The velocity of sound wave through a medium may be assumed to be dependent on first one is density of the medium, modulus of elasticity, deduce the formula for velocity of sound. Okay. So we have to, there are only two things dependent. One is the density and the other one is modulus. That modulus means the Young's modulus, the same one we can use. I've already given for your in the table what is Young's modulus. M1 L minus 1 T raised to minus 2. You can use same as your Young's modulus. So that's the modulus of elasticity. And then start. Deduce the formula for velocity. Velocity of sound means you have to find what velocity is related to. Don't put extra v here just because there is velocity again. Therefore, find a formula for velocity. So velocity is directly proportional to something will be a formula. And then calculate. Now, once you understand, you have to always work on your speed. Try to do it fast. Because you will notice for 20 marks, you will get only 1 hour. So from this, you'll get B as half. So definitely A will be minus half. Only two terms here, A and B. D will go down because this is minus. And this means root. This will be a relationship for velocity. Any doubts in this, you can ask. No. Next one, one last one based on this. I'll give some for you all. Okay, to solve. Either I'll send by today or tomorrow morning. The planet moves around the sun. Okay. A planet, the planet doesn't matter. Moves around the sun in nearly circular orbits. Its period of revolution T depends upon radius r of the orbit, second mass m of the sun, and third is gravitational constant g. Show that P square is directly proportional to R cube. Just put a star for this one and keep, because here no, this constant is not a purely constant. You have to find that gravitational constant first. It has dimensions. Because in the table, if you have noticed, we have found G. G is for, understand the difference, acceleration due to gravity. And this G is called as a gravitational constant. Even the word, there is a gravitational constant. It has dimensions. I'll show you how to derive also, but I'll write and give you first. You can write in the table somewhere and keep if you want to know. This is acceleration due to gravity, and this is gravitational constant. So anytime, either you know it by heart, or if your teacher is asking you to separately find gravitational constant and then substitute, you can do that also. Otherwise, if you don't want to do it separately, you can by heart this value. I'll show you how we get that. Just copy. Later in physics, we will come across this formula. Suppose if you have any two Earth, means two planets and all, any two planets, there will be always some kind of force between them. Okay, suppose if this one's mass is m1, this one's mass is m2. Any two bodies, okay? Suppose this is another planet and this one. And suppose the distance between them is r. Or small r. Then the relation between these two can be written as F is equal to G m1 m2 upon r square. So basically, if you want to derive this, you have to remember this formula. Force between any two bodies is given as the product of the mass m1 m2 upon the radius, whatever length is there between them. R is nothing but the length. And G is your gravitational constant. So now what do we have? F is the force between the two bodies. Now what we have to find? G we have to find. So G will keep on one side, remaining things will take on the other side. So this will go up. These two things will come down. G will keep here only. I want to find the dimensions for G. So this formula is a fixed formula which already exists. So using this formula, let me find the dimensions for G. So what I did, took this, now substitute force. So what is the dimension for force? Won't write and keep, F is for force, R is length, M1 and M2 means mass of these two bodies. Nobody will ask you to draw the diagram, explain and all that. And just start from here and then derive. So force will be 1, 1 minus R square means length. R is length. M1. This is not square, huh? This 2 means first one and second one. But it doesn't matter. This is also mass, this is also mass. So whether it's of the first body, second body, doesn't matter. M L T, the mass will be 1, will be 0. Again M L T, mass will be 1. This 1 and 2 is a subscript, it is written down. Don't make it as a power. Don't put 2 here. This is square. And this is just to indicate this is second body and this is first body. So don't put square here, it will go wrong. Both will have same dimensions because this is also mass, this is also mass. Now calculate. For square, so 2 will go here. Now add all the powers. 1 plus 0 will give me M1, L3. You can skip these steps. These are for those students who are still struggling with the basics. You may think who are struggling. Yes, there are many of them. 1, you take on top. Now this is in the denominator, so powers we are taking up. So that's what you will get. M minus 1, L3. So this is how we get the constant. So this is a dimension for gravitational constant. So in your college, if they are asking you to do this, first find out this and then substitute, you have to show this part, solving part. If they asking you directly use, then you can directly by heart this value and keep and substitute. So what was the relation? Now we'll write a relation. So the period of revolution, so obviously the time period it means, that is T, depends upon the radius of the earth, mass of the sun and gravitational constant. So T is equals to now you substitute. R means radius, that will be length. M means mass, only M will be this. And G just now we got to put it here. Radius means length, mass will be 1. And now solve. So C is minus 1 by 2. Then take B minus, so B minus C is equal to 0. So B is equals to C. C is also minus 1. B also will get as minus 1 then. And then last one, A plus 3C is equal to 0. So minus 3 by 2. Take it on the other side, A is 3 by 2. Okay, we'll substitute. M raised to, this is R now, minus half G raised to minus half. Now this will go to the denominator. Both are negative, so both will go to the denominator. Now here, if any time no in problem solving, if you come across only this particular number, 3 by 2 suppose. So I'll just tell you what is to be done. The rough column 3 by 2 can always be written as 1 plus half. See, 3 by 2. If you cross multiply, you'll get 3 by 2. So 3 by 2 can be splitted as 1 plus half. And which is nothing but, if you split the powers, it will look like this. X raised to A plus B can always be written as X raised to A into X raised to B. So that way I'll write here. So half means always root. Dot means multiplication. Okay? So this will become root of R. This will become root of M. All are roots, so they will go under one root. Everything common. So this will be our answer. That R raised to 1 is R. Any doubts in this, you can ask. So whenever you get raised to 3 by 2, always do like that. Even here, this is not wrong. Okay. Till here also it is correct, but this is the way to write the formula. Now we'll move on to the next topic. Same chapter only. Subtopic called as errors. Error mean you know that kind of a mistake. But as per the normal definition point of view, the uncertainty Uncertainty means not sure. Okay, unsure. Certain means you're sure of, but when you're not sure of something, it is always called as uncertainty. It was uncertain that an accident happened today, so you were not sure that it would happen. So suddenly, if it happened, that would be uncertain. Now, how to know what is an error in terms of basic life? Suppose if I go and buy a ribbon, suppose. Okay, I say give me a 5-meter ribbon. So the shopkeeper, whoever gives you 5-meter ribbon, you come home and then you try to measure it again. Now, not necessary that you might get exactly 5 meters. Sometimes you may get, when you are measuring, you may get it as 5.001 also. So 5.01 is slightly bigger than 5. Okay, or you could get slightly smaller than that also. Even this could be 0. I'm just giving this as an example, not that you will get this only. Could get it as 5.02 also. So now what this is called as a exact value which you had asked for. Now if you see your number, your exact value has changed. So by how much you can see the difference. 5.01 minus 5. Nothing is there, means it means 0, 0. So your, how much is your error? 0.01. Okay. Same way you can try this other way around. 5 minus 4.99. This case also. So plus minus we will not bother it right now. Later we'll see. So how much is the error? 0.09. Either it could be plus or it could have been minus. So how do we denote it? Is always by the word delta. So if this was my x, okay, if this is x, then it would be called as delta x. So over here, what is delta x? 0.01. So it is what? How much extra or less it is from what you should be actually having it. You should be getting exactly 5 meter, but you are getting something either smaller or slightly different from that. So that difference is called as an error and always denoted by this word delta. So whenever you come across this delta, you know that it indicates the word error. And doubts in this? You know, basic, that is, any change from the exact value is called error. Now, there are two types of error. One is systematic error, and the other one could be random error. The systematic error is when the cause of error is known. Cause of error is known means you know what is the reason for the error. So while measuring the ribbon, you would know whether the shopkeeper or this, okay, or even consider. Now you have a weighing scale, suppose. Okay. one side you are putting some stones, okay, on the measuring, and then you try to weigh, normal weighing scale. So what it should come to a normal level whenever you try to put weights on this side. When you know some amount of dust is present here, so definitely every time you measure it, you measure 1 kg of rice and give it to someone. When that person goes and checks it, he will get it less, but you had measured it properly 1 kg because you had ignored that this dust was there. Now you know that the dust was there, okay, of how much ever layer, like it is contributing even 1 gram also. Now errors will be even in small terms also. So now you know the cause of error is your dust. So mostly the systematic errors can be removed. Errors can be removed. What means you can clear off the dust and then you can measure. Because the moment you know the reason for the error, automatically you will remove out that reason. Suppose you know that when you were measuring your ribbon, your scale was suppose faulty. The ruler which you were measuring was faulty. So definitely you will not use that ruler again if that was faulty. Okay. So the moment you know the cause of error, you can always remove it to avoid any mistakes. Now random errors are the ones cause of error is not known. The cause of error is not known. So that will be in the case like you don't know whether you are measuring it wrong somewhere. Like in the, especially if you do practicals, you will understand this. Later on, they'll be giving you many instruments and all, like something called as vernier caliper and spherometer and all. They're different, like how we have normal scale, no, like that we have different measuring instruments. So while measuring, no, every time you might get different, like in point millimeter and all. So sometimes you don't know whether the instrument is faulty or whether you are faulty. Your way of doing that error is faulty. So you exactly don't know what is the reason you're getting that error. So in that case, it is called as random error. So you just have to keep trying and changing. You try to change your instrument and see, then you try to change your method of measuring and see. So that is, you just have to keep on trying till you get the correct value. Just here, you know, it can be removed in the first place itself. And systematic errors, okay, they are also like they'll change in one particular direction only. Also, it also means that this error, I'll explain what it means. This error tends to shift the result in one direction only, either positive or negative. What it means is, now you have a weighing machine at home. You check your weight, okay, or you check whatever you weigh. That time you check your mass. Now we know that in physics that you check your mass, whatever you're standing on. Suppose your instrument itself is faulty, and already instead of showing it as 0, it is showing you it as 0.3 or something, or whatever it may be. By default, the instrument is faulty. So he's already adding something, some 50 grams to it already. Every time you measure your weight, what is going to happen? It will give you something more than what you weigh. Any person also goes. Suppose if you were exactly measuring 40 kgs. So 40 plus 50, it will always give you. Another person comes up and stands there, 50 plus this 50 kg plus 50 grams. Okay, so always it will give you positive only. Now just because the other person, someone else came, he will not minus 50 grams and give me, because this is already plus. So either it will give you positive. Suppose if you are having a pressure, blood pressure when you want to check. Now this fellow is showing some negative. Suppose the person's pressure is 120, but he is trying to show it as 115. Another person comes, his actual pressure on the correct instrument was 130. Then he'll be showing 125. So same way, someone has 140, then he would be showing 135. So either it will show less for every person, or it will show plus for everything. So it tends to shift in one direction only. So whenever there's an error, you know that it remains constant for every person. Suddenly it will not show negative. So this type of error is called as a systematic error. So if it is a positive error, for every person you check, you will give that same positive error. Suppose if he has a negative error, tendency to show lower value than the actual one of the person, then for every person he will show less only. So then you automatically know if your instrument is faulty by 5, next time when you check, if you are getting it as 95, you know that it's actually 100. So that is what, okay, because you know your machine is giving you 5 less. So those type of errors are called as systematic errors. And random, you don't know the cause. So you cannot try out. You can just keep trying and see. Anyone who has not understood systematic and random, no one will ask you to explain so much in details. Okay, one sentence or one definition might be asked. Depends on the college also. They don't do too much of theory also in that. So if they give you proper, I'll give you anyways the definitions. In college, if they're asking you specifically to study for exams, then you can study. Otherwise, you can just ignore. Just have to know, because more of problems are there based on this. Then the next two terms based on errors which you want to know is accuracy and precision. Accuracy and precision means, quickly I'll explain. Suppose if I have the values, and here if I have if you have something called as an exact value, which we had checked for the ribbon, 5 meter. So I just want to tell you what is the difference between accuracy and precision. Now you brought that 5 meter ribbon at home. Someone tried to measure different values. Someone got it as 5.10, someone got it as 4.99, 5.112, and this. And some of them, if they try, they might get like this, close to this. If your scale is very this good, you might get like this. Now, accuracy, if you see, these values are very close to here. 4.99 is very close to 5. Even 5.10 is very close to 5. 5.12 is also very close to 5. Even 4.97 is quite close to 5 meters. Okay, so what the definition says is, these values are very close to the exact value. But among them, you see, there is so much of difference. 4.99 is not extremely close to 5.1, because 4.9, then 5, 5.1, 5.2, 5.3, that way it will be. Okay. See, even 4.97 and this, if you try to compare, almost lot of difference is there. So many points difference is there. But if you see over here, they are very close to each other, just 0.01 difference. They are in the same range, but this range is very vast. Okay, so the definition is the values are very close to this value, these values, every corresponding value, but among themselves, they are not close. But not close to each other. And over here, what is the difference? Values are close to each other among themselves. Okay. But very far from this. This is like 5 meter they are showing, and this fellow is telling 6 meters. So 1 meter difference is a big difference. Good, but not close to the exact value. So that is precision, and this is called as accuracy. Among themselves, they may be far away, but they are very accurate compared to the exact value. Here they may be precise, means very close to each other, but they are far away from the main value. This is the difference. And just small 2 words, 2 more this, one more time. Instrumental error and personal error. The word itself you'll understand. What will be instrumental error? Definitely if your instrument is faulty. Error due to fault in the instrument. And personal error will be error during measuring. Like when you are measuring, you may be like ribbon, you are not holding it properly. You are trying to measure from here to here maybe. The scale you must not be holding exactly here. So it is your fault that you are not able to measure it properly. The ribbon might be exactly 5 meters, but you are holding a scale here. Okay, so that is called as a personal error. So these are the basic theoretical types of errors. Means only the theory part if you know about these things. Now the main problem wise, they called as absolute error, relative error. So that we'll do in the next class. About this, the definitions I send you in the group. Just one definition, line definition it is. You can just copy on your notebook and keep. That I don't want to dictate now. I'll stop here. Don't leave. I'll take attendance.